In this video, we're going to focus on the International Union of Pure and Applied Chemistry system of naming alkanes. Now, the first thing we need to do is to know the names that we give or we assign to carbon atoms. How many carbon atoms in a particular compound? For example, if we have only one carbon atom, like the simplest alkane, remember alkanes are single bonds. The simplest alkane is C4, that's CH4. This is how it looks like. So this is methane. So 1 is methane, 2 is ethane, 3 is propane, 4 is butane, 5 is pentane, 6 is hexane, 7 is heptane, 8 is octane, 9 is nonane, 10 is decane, 11 is undecane, 12 is dodecane, 13 is tridecane, and so on. So, for example, if I'm to name this compound, every junction means there's a carbon atom there. So there's a carbon atom here, 1, 2, 3, 4, 5, and 6. So, and 6 happens to be hexane. So this is hexane. If I'm to draw it, it will be C123H. So this is how it looks. 1, 2, 3, 4, 5, 6. So the C's, carbons in the middle, they have only 2 hydrogens. So because every carbon must carry maximum of 4 bonds. So the one at the edge carries 3 hydrogen atoms. If I'm to write it, it will be CH3, CH2. So this is CH1, 2, 3, CH2. So another CH2. That's for this. For this, another CH2, another CH2. So that means the last one will now be H3. So 1, 2, 3, 4, 5, 6. So this is how it is. So when a carbon atom loses one hydrogen atom, when an alkane, for example, loses one hydrogen atom, it becomes an alkyl. So this person is pronounced methyl, for example, in case if we see it as a substituent, that's as an attachment, or what we call a branch. For example, if I have now let's say here, for us to name this, the first thing we need to do is to identify the parent chain, which is the longest chain. We have 1, 2, 3, 4, 5, 6, 7, and 8. Now, it means at this carbon atom here, there is another C, H3, that is here. So, which means there is a branch here. So the first thing we need to do to consider this branch, we name it in such a way that this substituent here will carry the lowest possible number. So if we are naming from left to right, it will be the carbon number 3 that is carrying it. But if we start naming it from right to left, we have 1, 2, 3, 4, 5, 6, 7, 8. So it will be number 6 that is carrying it, which is not supposed to be so. So the third carbon atom is the one carrying it. So we already have 8, and 8 is octane. Octane. So it means at the third carbon atom, we have a methyl. So we say 3-methyl. We use a hyphen to add or to join number and alphabet. 3-methyl octane. So at the third carbon atom, there is a methyl attached to it. Then the parent name is octane. Now, what if we have What if we have this, and let's say we have this? There's methyl here, there is methyl here. The first thing we also need to do is to identify the possible longest chain, which is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, that is the longest chain. Should we name it this way, from left to right, or should we name it from here to here? If we name it from left to right, we notice that those carrying the substituent, that's a methyl group is here, a methyl group is here, is 2 and 3 carbon atom. If we name from here, those carrying it will be 1, 2, 3, 4, 5, 6, 7, and 8 are carried, and 9, 7 and 8 will be the ones carrying it. And remember, 2 and 3 are lower than 7 and 8. So we're going to say 2, 3 dimethyl means we have 2 methyls, which is dimethyl. 9 happens to be nonane, so we say nonane. So we give them the lowest number possible, because from here is 2 and 3. We use a comma to separate two numbers. We use a hyphen to separate numbers from alphabets. So if we have 3 substituents like the same methyl, it becomes trimethyl. If there are 4 substituents that are methyls, it becomes tetramethyl. So let's see another one. So let's name this. If we start from here, 1, 2, 3, 4, 5, 6, and 7. If we start from there, remember 7 continues to be heptane. 7 is heptane. So we need to name here. There is a substituent. There's a substituent. Here there's also a substituent. Now we will name this to show where these substituents are, giving them the lowest number possible. Now if we start from here, it will be at the 4th and 5th carbon atom. But if we name it from here, if we name it from right to left, it will be 3 and 4. So 4 and 5 is higher than 3 and 4. So we're going to pick 3 and 4 instead of 4 and 5. So which means heptane being the parent chain, we have 3, 3. We're going to write 3 into 2 because at that 3 it has double methyl group. So 3, 3, 4 trimethyl. 3, 3, 4 trimethyl heptane. That's the name. If we're to open it up, so make it look like to draw this C, so what it means is that at the 3rd carbon atom, which is this, it carries another methyl group. So the rest are now at the 4th carbon atom carries only one methyl group. The 4th carbon atom carries only one methyl group. The 3rd carbon atom carries 2. That's this. The 4th carbon atom carries 1 methyl. So the rest is now just 1 hydrogen, 1 hydrogen. So that's to open it up. So let's also consider this structure. If we are naming it, we can say 1, so which is heptane. Now, we have at the third 3-methyl. Fourth, we have ethyl, 4-ethyl heptane. Now, should we mention methyl first, or should we turn it upside down and say 4-methyl, 3-methyl, 4-ethyl, 3-methyl heptane? Which one is the correct one? In the first one, you notice that the numbers are in ascending order, 3 before 4. In the second naming, you notice that they are in descending order, 4 before 3. Now, what we need to consider is that whenever we have alphabets, ethyl, E comes before M. So because of that, even though both are substituents, the E comes first. So we're going to pick the appropriate one to be 4-ethyl, 3-methyl heptane, because E comes before M. Let us also consider this structure. If we name from left to right, we have so the longest chain, octane, 8. Now, we have from here at the 4th carbon atom, we have propyl attached to it. At the 5th carbon atom, we have ethyl attached to it. So, if we are naming in this direction, we can say 4-propyl, then 5 we have ethyl, 5-ethyl, then octane. Remember, according to the last example that we gave, we said E comes before P. So, because of that, we can say 5-ethyl, 4-propyl, octane. So, now, there's also another way. If we are to name it this way, let me draw the structure. If we are to name it this way, now, it means that at the 4th, we have 4-propyl, ethyl, 4-ethyl, 4-ethyl, then 5-propyl, octane. Now, no matter how we do it, you can notice that here the only difference is that the numbers are in descending order, 5 and 4. Here is in ascending order or increasing order, 4 and 5. In whichever way we see them, we notice that alphabetically they are already arranged, E before P. Now, all we now need to do is that since they are already arranged, in any way we put it, they are already the same. What we now need to consider is the number. We now need to put it in increasing order. So we pick 4-ethyl, 5-propyl, octane. Now, what of when we are asked to draw? We are given a name already. For example, this says write the structural formula of, first one is 2-dimethylpropane. This is the parent name. So propane means 3 carbon atoms. 1, 2, 3. So that's the 3 carbon atoms. It said 2-dimethyl. It means at the second carbon atom, because in anywhere you count from, this is the second carbon atom. So at the second carbon atom, there is dimethyl. So there is 2. 2 means di. 2-methyl CH3. Then that's what it means. So that's the structure. This is 2. We have 1, 2, 3. 2-dimethyl propane. The next one says 2-methylpentane. 2-methylpentane. Pentane is the parent chain. So 5 carbon atoms. 1, 2, 3, 4, 5. 5 carbon atoms. 5 carbon atoms. 1, 2, 3, 4, 5. 5 carbon atoms. So 2-methylpentane. So we either come from here or come from where. So if we are coming from here, this is second. So at the second carbon atom, there is methyl. That's what it means. Two-methylpentane. The next one says 2,3-dimethyl-butane. So it means that butane is the parent chain, the longest chain. So we bring it butane, 4 carbon atoms. 2, 3. So even if you're coming like this, this is 2 carbon atom. 2,3-dimethyl. It means at this there is a methyl. At the third one there is also a methyl. 2,3-dimethyl. Butane. So 2,3-dimethyl-butane. The next one says 1 bromo, 2 chloro, cyclohexane. So cyclohexane is the parent chain. So we give the cyclohexane 6 carbon atoms. Cyclo means it is a closed. So we can start from here. 1 bromo, 2 chloro. So 1, 2, cyclohexane. Then the other one says 1,3-dimethyl cyclopentane. So we first of all draw cyclopentane. 5 carbon atoms. 1, 2, 3, 4, 5. Cyclopentane. So at the first place there is a methyl. At the third, say let's say 1, 2, 3. At the third place there is also another methyl. So 1,3-dimethyl cyclopentane. So if you have not subscribed to my channel, please try and do that now. Thank you.